So here in our first example, suppose that z equals xy squared. At a certain instant, when x is 2 and y is 5, x is increasing at 6 units per second, and y is decreasing at 1 unit per second. How fast is z changing at this instance? So let's summarize what we know. We know that we have this function here, z equals xy squared. I'm going to leave some space to take the derivative here. I know we're focused on when x is 2 and when y is 5. And at that instance, x is increasing at a rate of 6 units per second. So to me, that means the change of x with respect to time is a positive 6 because it's increasing. And then at that same moment, y is decreasing at a rate of 1 unit per second. So that means dy dt, the change of y with respect to time, is negative 1 unit per second. So let's differentiate first and then plug in what we know so that we can figure out how fast z is changing. So we're looking for dz dt, the change in z with respect to time. So now I can differentiate implicitly with respect to time this function involving these 3 variables. So what is the derivative of z with respect to time? It's 1 dz dt. Now that's what we're looking for, right? The change of z with respect to time. So this equals, well, this is a product rule between 2 functions. The derivative of x with respect to time is dx dt multiplied by y squared plus x multiplied by the derivative of y squared, which is 2y. But we're taking the derivative with respect to time, so I need to do chain rule, multiplied by the derivative of y with respect to time. So now I've created an equation that relates the rates of changes of these variables with respect to time. So now if I'm looking for dz dt when x is 2 and y is 5, I can plug in what I know and figure it out. So dz dt equals dx dt, which is 6, multiplied by y squared. We're at the instance when y is 5, so 5 squared, plus x, which at this instance is 2, multiplied by 2 times y. And then I can't forget dy dt, the change of y with respect to time, which is negative 1. So now that I've plugged in everything I know, I can simplify this. dz dt equals 6 multiplied by 25, which is 150, plus 10 times 2, which is 20, negative 20. So dz dt is changing at 130 units per second when x equals 2 and y equals 5. So that is the instant when it is changing at that rate of change. So it is increasing. Don't forget to say that. Since it's positive, it is increasing 130 units per second when x equals 2 and y equals 5. All right, let's try one that's a little more applicable to life in our next example.